Hi grade 10s, today is an introduction lesson to trigonometry. In grade 10, all of our trigonometry will be in right angle triangles, and we'll go through a couple of examples. We'll teach you how to label your triangle correctly and then how to put your triangle ratios together for each specific trig ratio. So on the screen, we're first going to learn how to label our triangle. So the first thing we notice is that there is a right angle triangle. So the side opposite the right angle, as you can see there, is called the hypotenuse. Then we show our new angle, it's called theta, which is a Greek letter, and you will need to get used to working with Greek letters. Whichever side is opposite our Greek letter is labeled opposite, and the remaining side of our triangle is then called adjacent, as you can see on the screen. So every single triangle that we will work with is right angled. We will first need to label it hypotenuse, opposite, and adjacent. Now it's very easy when the triangle is working out very nicely for us, but if they start rotating that triangle, it starts to get a little bit more complicated. So we're just going to have some practice on how to work with that. Okay, on the screen you should see some new letters right over there. So the first one, and I use it in the top triangle, is called theta, a Greek letter, and then alpha, beta, and delta. These are just Greek letters that represent values that we don't know. So they're angles, so we still have to calculate the size of the angle. But right now we're not worried about angles, we're more worried about the sides of the triangles. All right, so if we go up, says there our first trig ratio is called sine, but we spell it S-I-N. So we don't say sin, we say sine. Then our next one is cosine, which we will abbreviate to cos. And then the last one is tangent, which we will abbreviate to tan. So our three ratios are sine, cos, and tan. And what we need to determine is how our three sides of our right angle triangle translate into each of the ratios. Okay, so if that angle over there is theta, as you can see, that's the angle. And we were to label this triangle. The side opposite theta is called opposite, and the side opposite the 90 degrees is called hypotenuse, and the last side is simply adjacent. And in maths, adjacent means next to. What we now need to do is put each trig ratio together in terms of the three sides of the triangle. So each trig ratio only uses two of the sides. And there are many different rules and funny rhymes that you can remember to put these things together. So sine theta is always opposite over hypotenuse, and cos theta is always adjacent over hypotenuse, and tan theta is always opposite over adjacent. But that's very difficult to remember. So you can learn any rhyme to help you. You could be posh and you could learn Sir Oliver's horse came ambling home to Oliver's aunt. And as you can see here, Sir Oliver's horse came ambling home to Oliver's aunt. So that tells you how to put your ratios together. So if we were to write here, Sir Oliver's horse. So it tells us that it's opposite over hypotenuse for sine. And then for cos we can say came ambling home. So cos is adjacent over hypotenuse to Oliver's aunt. So tan is always opposite over adjacent. And they will ask you to put these ratios together. And remember that ratio actually means fraction. So we need to take two sides and put them together for each trig ratio. And then you learn your little rhyme. Some teachers use silly old hens cackle and hackle till old age. It's up to you how you want to remember it. Okay. So we're going to work on some triangles now and put our trig ratios together. So if we take our top triangle, remember we're always working in right angle triangles in grade 10. If that is angle theta, we first have to label our triangle. So this will be our hypotenuse, that will be opposite, and therefore this will be adjacent. So let's say we had the hypotenuse was 5 units long, and opposite was 3 units long, and adjacent was 4 units long. We can now put our 3 trig ratios together, and we write it as follows. Sine theta is equal to opposite over hypotenuse. Now you go to your triangle and you go and you look how long opposite is. Opposite is 3 units, so you write it down. And you create a fraction. Hypotenuse is 5 units long. So our trig ratio for this triangle, just for sine theta is 3 over 5, and that's it. Next we would put cos together, so we'd say cos theta is adjacent over hypotenuse. Adjacent in this diagram is 4 units long, and our hypotenuse is 5 units long, and we're done. Then the next one would be tan. So tan theta is opposite over adjacent. So our opposite is 3 units long, and our adjacent is 4 units long. And there we are done. We have put our 3 trig ratios together from our first triangle. Okay, in our second triangle, so there's our right angle. Let's say they gave us angle alpha instead of theta. It doesn't matter which Greek letter they use. The point is that it represents an angle. And you would label your triangle exactly the same way. So opposite the right angle would still be hypotenuse. Opposite the given angle, alpha, would still be opposite. And our last side would still be adjacent. So let's say we had 3 for adjacent and 5 for opposite. We could calculate the hypotenuse using Pythagoras. So the hypotenuse in this one would say 5 squared plus 3 squared. So our hypotenuse squared would be 25 plus 9. Therefore our hypotenuse squared gives us 34 units. So our hypotenuse is the square root of 34. And that was from Pythagoras. So you will notice that every time you use a right angle triangle, you can use Pythagoras to help you as well. So if we want to put our 3 trig ratios together for the second triangle, we start with sine. So we say sine alpha this time, because we don't have theta, we've got alpha. And remember that sine is opposite over hypotenuse. So it will be 5 units over the square root of 34. And then you are done for sine. For cos, we would say cos alpha is adjacent over hypotenuse. Adjacent on our diagram is 3 units long over the square root of 34. And then we are done with cos alpha. Lastly, we'd put tan together. So tan alpha is opposite over adjacent, which would give us 5 over 3. And there are our 3 trig ratios. So the method is always the same. Label your triangle first, then put your trig ratios together using your rhyme. All right. If we look at our third one, if that is our right angle and that was our given angle, so beta, we've now changed the letter again to get used to working with Greek letters. And let's say we had 3 and 2. We first have to label this triangle. So we would have the hypotenuse over there, opposite the right angle. Opposite would be exactly the same, opposite angle beta. And the remaining side is adjacent. And we always label in that order. Hypotenuse first, and it's directly opposite the right angle. Then we go to our Greek letter, and we go to the opposite side of that, and we label that side as opposite, and then the remaining side is called adjacent. And from there, we are able to put our 3 trig ratios together. So sine is opposite over hypotenuse, so we will get 3 over, and now we see we've got a problem. We haven't actually calculated the length yet of our hypotenuse. So we first have to calculate that using Pythagoras. So we would say 3 squared is 9, and 2 squared is 4, and together we would get 13, which we would take the square root of, if you practice your Pythagoras correctly. So sine beta is therefore 3 over root 13 in this diagram. Cos beta would be adjacent over hypotenuse, which would be 2 over the square root of 13. And then you're done with cos. And lastly, we need to do tan beta. And tan is always opposite over adjacent. So we would get 3 over 2. And then we are done with our third triangle. So it's the same steps every single time. Label your triangle correctly, then substitute the sides of that triangle correctly into each individual trig ratio, and then you're done. All right, and our last triangle, let's say that was your 90-degree angle, and this was angle theta. First thing we would do is we would label this triangle. So there's your hypotenuse, opposite the 90 degrees. Opposite angle theta, we shall label that opposite, and our last side is adjacent. So let's say our hypotenuse was 7 and opposite was 2. We would first have to calculate adjacent using Pythagoras. And Pythagoras says if you have the hypotenuse, you must square the hypotenuse minus the short side that was given squared. So we would say 7 squared minus 2 squared. So that's saying 49 minus 4. So we have the square root of 45. So adjacent is the square root of 45. And now we can work out our 3 trig ratios. Sine theta will be opposite over hypotenuse, which would be 2 over 7 in this diagram. Cos theta is adjacent over hypotenuse, which will be the root of 45 over 7. And then tan theta will be opposite over adjacent, which is 2 over the root of 45. And then we are done. It's that simple to label your right angle triangles. And the reason why these right angle triangles are so important is later we're going to move on to the Cartesian plane. And everything we do on that Cartesian plane in grade 10 is going to be in terms of right angle triangles. So we need to know how to label it very carefully so that when we are working on the Cartesian plane later on, we don't get stuck. We know exactly how to do it. And that's our lesson for today. Thank you.